Yes, class. So in the last class, we had completed few questions from current electricity, right? So some of the DC circuits we couldn't discuss in the class itself. So separate these circuits, let us do. Then from tomorrow, we'll start with magnetics. Chapter 4 of NCERT, that we'll start. So I'll write down the question, try it, then I'll discuss. This question says that the effective resistance of a parallel connection that consists of 4 wires of equal length, equal area of cross section, and same material. This is how much? 0.25 ohms. Now you have to find out the effective resistance if they are connected in series. Now see, 4 wires are there and they are identical. Length is same, area is same. So don't we know the formula? R is equal to rho L by A. Length same, area same, same material. So can't we say resistance is equal for both the wires? For all the wires, not just both. Let's say all are equal to this R. And R equivalent is also given, that is 0.25 ohms. It means one by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4, like this. Right. Now what is saying in the question? All these are equal. So instead of writing this as R1, R2, R3, and R4, I can write it as directly this as 1 by R plus 1 by R plus 1 by R plus 1 by R. And what is R equivalent already mentioned? 1 by 0.25. So this will become 4 by R. This is also 0.25 is actually 1 by 4 only, and 4 by R. So from here, we can say R is 1. Now, if these resistors, they are connected in series, so R equivalent will be 1 plus 1 plus 1 plus 1, that is 4 ohms. So correct option was option D. Noted down those who haven't. No. I'll discuss some other questions with you. So only Samaira could answer this. Others, what about you? Yes, Samaira, your answer is right. See, let me discuss it now. It says across A and D. Whenever now it says across 2 points, it gives you any 2 points. Do one thing, connect a battery immediately, so that at least it is visible to you. But here in this case, that is also not very much needed. See, let me do one thing. Let me name all the resistors. R1, these are also 10 ohm because it is not given the question, otherwise the answer won't be there. This has to be 10 ohm. So this is R2, R3, R4, R5, and 6, like this. So see, R equivalent, if you take the R equivalent between this one, no, connecting battery. See, connecting battery, when I say connecting battery doesn't mean that you are actually applying it. See, whenever in not in this circuit, but in most of the circuits you must have seen, no, there's a trouble whenever you are having, I'll show you it. See, suppose this is a circuit given. Usually we have this with us. So it becomes clear, no, this is R1, this is R2, these are the registers, we have to solve it. Suppose this is not given in this manner. If I say this is given like this, A and B. Now what will you do? Can you identify it's in series and parallel? And what about if it's a complete circle? Then otherwise it becomes more difficult to identify whether it's series or parallel. So best thing is that connect a battery. As soon as you connect a battery in between those 2 points, no, you are able to see exactly which points you are connecting, as well as you're able to see which resistors are in series and parallel. That's what is meant by it. Here you can leave it. Here it's there is not so much need. Here, right now, you just have to take out the series combination and parallel combination. That is sufficient, right? Here you just need to take out the series and parallel combination. That is sufficient. Whose resultant will be in series, that is a different thing. So if you start from here, or if you start from here, you have to start from here, or you can start from here in this manner. All right, so connecting a battery means if it is saying 2 points A and D, so between this point and this point, now a battery has been connected. So when the battery is connected, you will see they are in series now. This part and this part, they are already tied with each other. So what will happen? Resistance, this will be directly, you can add it also in series. R1, I'll write it as R1. This will be 110 and all are 10. No, so this is going to be 20 ohm. Now this 20, this is in series with the left one. All right, take a minute. If you were you were having confusion regarding this. All right, last minute then, but quickly try it. Whatever answered, because till now only Samaira has answered. Fine, okay, take a minute. Class, I'll start the discussion. Otherwise, this will take a lot of time. All right. So I was saying, yes, you keep on trying. It's okay. And whatever answers you get, let me know. So if this is your point and this is your point, this is a battery altogether for you. So what you can do for the ease of calculation, just draw this part. Whichever part is not involved, you are having confusion regarding how 20 came. No, so it's better if you draw the circuit which is of your concern. As in, point A is there, 10 ohms, another 10 ohm is connected. Now, instead of extending this to point B, which is not of your use, direct extend it over here. Now look, here we had B. I'm not drawing B because now B is of no use to us. Here we had C. Now we won't draw C. But we want connecting point between D. So this is it. Now see, now when you see, I hope now it will become a little more clear. You can see they are connected in series. This is what I had written. No, when I wrote no R1, R2, they are equal. So here you can see, let's say R1, this is R2. So R1 plus R2 becomes 10 plus 10, which is equal to 20 ohms. All right, this is first one. Second, they are connected in series. So let's say this is R3, this is R4. So again, R3 plus R4 will also be 10 plus 10, that is 20 ohms. Right? This is 20, this is 20. Now look here. Just forget these two right now. Just look here. Instead of this part, I am having one resistor which is 20 ohms. And instead of this part, I am having one resistor which is of 20 ohms again. So can I redraw it in this way? This is 10 ohms. This is a point. In here, I had, let's say this is 20 ohms which we are getting. This is also 20 ohms which we are getting. And this is the 10 ohm connected along with it. Here, can you notice this? They are connected in parallel. Let's say this is some R1 dash and R2 dash. So R12 dash, their equivalent, this is going to be R1 dash into R2 dash divided by R1 dash plus R2 dash. The way normally you calculate parallel combination. So I have told you, whenever you have identical resistors, no need to do this method properly. No need to perform this entire method. This will take your time. Simply divide, if the resistors are identical, divide by number of resistors. What is the value of resistor? 20. How many resistors are there? 2. So 10 ohms. Finally, instead of these two resistors also, what can we conclude? 10 ohm. Instead of this also, we are having 10 ohm. And we already had 10 ohm for point D. So now you can see all they are connected in series. So our equivalent will be 10 plus 10 plus 10, that is 30 ohms. So which option was it matching? C option. All right, so this is C option. Note down those who haven't written it. class, this is a question from heating effect of current. So these are also included in your NEET exam. These questions have come. A lot of questions come from these, especially the bulb and these heating part does come. So the charge following through a resistance varies with time in Q is equal to AT minus BT. So just a second. All right. So yes, charge is given as Q is equal to AT minus PT square. Now current is what? Current is rate of change of charge, dq over dt. So right, what is given? What is the value of Q? AT minus PT square. This is what is written. So if you differentiate it out of A and T, A will be the constant, T is 0. Minus 2 is the power, so 2b T, because T to the power 1 to the power 2 minus 1 will be 1. So I is equal to 2bt. You have current. From charge, you have calculated current. Now see, maximum value of T is till the time current isn't 0. So you have to make it as 0 for maximum value of T. So A minus 2bt will be 0. So A is equal to 2bt. T is equal to A by 2b. H is equal to, now this is the formula which you have to use. H is equal to I. Directly use H is equal to I square RT, or if this is given in variable form, then integrate it. All right, I square R dt. From time is from 0 to A by 2b. This you have to integrate and solve. Whatever will be the answer will be your final answer. So see, value of current we have calculated, A minus 2bt whole square R dt, integrating it from 0 to A by 2b. So what we can do one thing, we can open this identity A minus 2bt whole square. A minus 2bt whole square, we can open this using identity. So this is A square plus 4b square t square minus 4abt r dt, integration from 0 to A by 2b. So H will be A square t plus 4b square t cubed by 3, once you put the values, minus 4ab t square by 2. Limits will be 0 to A by 2b. So instead of t, wherever you are having t, you just have to put A by 2b. Right, so when you solve this, put these values in here. When you solve this, this will be equal to A cube R by 6p, which is option D. Note it down. Wherever doubts you are having, let me know. And mark this question as important. This is from your previous year question only. Here use the formula. A filament bulb you have whose power is 500 watt. Voltage is given as 100 volt. It is to be used in 230 main supply. When a resistance R is connected in series, it works perfectly and the bulb consumes 500 watt. The value of R is. See, use just this formula. That is sufficient. P is equal to V square by R in all the questions which you have. Also, you have a formula P is equal to VI. So from here also you can get the value of current as P by V. So P is 500, V is 100, current will be 5 amperes. Now you have current. So resistance of the bulb. See, this is saying when resistance, when a resistance R is connected in series. So it works perfectly and the bulb consumes 500 watt. So 500 watt is being consumed, 100 is the voltage. So directly you can use 100 into 100, V square by R. R is 500. That is 20 ohms. Now this R is connected in series, right? R is two 230. This is given. So R plus whatever R is in series. So R plus 20, this will be 230 by 5, which is 46. So R is equal to, from here 20, subtract 20, so 26. It's just that you just have to use this formula. P is equal to V square by R, and these are important formulas. See, an electric kettle takes 4 ampere current at 220 volts. Now, how much time will it take to boil 1 kg of water from temperature 20 degrees Celsius? So these are the value of time given. See, you must have done change in heat is ms delta T when the temperature is changing. So here also temperature is changing. So how much time will it take to boil 1 kg of water from temperature 26 degrees Celsius? So using this, and you already have a formula which I have told you, VIT. This you have to use. So you can equate both these formula. This is also heat, VIT. So once you equate it, ms delta T, from here T will be, this is change in temperature, this is time. So how much is 1 kg is given? So this is 4200 into 80 divided by 220 into 4. So this is 81.82 seconds, which is equal to 6.3 minutes. Note it down, just text me done once completed. M is mass and S is specific constant.